Welcome to The Explainer, where we break down big ideas using the material that shaped them. You ever wonder why a solution that seems so obvious just completely fails? We're going to get into that today and look at how a totally different way of thinking can help us find fixes that actually, fix things. Okay, let's dive right in with a puzzle that seems to defy all common sense. So picture this. A program in Kenya gives out free textbooks to schools. The idea is kids don't have books. That's the problem, right? Makes perfect sense. Except a major study found it had literally zero effect on the average student's test scores. So what on earth happened? How is that even possible? And here's the thing. This isn't some weird isolated case. It's actually a super common problem. We see an issue, we throw what seems like a totally logical solution at it, and poof, nothing happens. Or even worse, the problem actually gets bigger. Well, the brilliant systems thinker Donella Meadows had a really powerful insight into this. She said, we're almost always blaming the wrong things. We point fingers at the leaders, the immediate events. But the real reason something behaves the way it does, whether it's the economy or even just a slinky bouncing in your hand, is its own internal structure. And you see this pattern all over the place. That management reform in India, it flops. The push for more STEM teachers in the Netherlands falls flat. On the surface, these all look like totally separate, unique failures. But they're not. They're all just symptoms of the exact same mistake. We're trying to fix a complex system by poking at the wrong part. All right, so how do we get off this merry-go-round of failed solutions? Well, it all starts with a shift in perspective. We have to stop staring at the individual pieces and, learn to see the whole board. We've got to understand what a system is. Donella Meadows had this fantastic way of explaining it with a simple toy, a slinky. Think about it. You hold a slinky, you wiggle your hand, and it does that amazing bouncy wobbly thing, right? Now, if you do the same thing with the cardboard box it came in, it just kind of dangles there. The behavior, that bounce, it's not just coming from your hand. It's coming from the slinky's structure. And that's true for every single system out there. Okay, so what are we actually looking for when we say system? It's got three keyed ingredients. First, you've got the elements. These are the parts you can see, the obvious stuff, like, the players on a football team. But here's where it gets really interesting. The second ingredient is the interconnections. These are the rules of the game, the way the players communicate, the playbook. And then third, you have the system's function or its purpose. And listen, this last one is often the most important and the most surprising because a system's actual purpose might be totally different from what everyone says it is. Okay, let's make this super simple with a bathtub. Imagine the water that's actually in the tub at any given moment. That's what we call a stock. It's just a pile of something you can see and measure. It could be water, sure, but it could also be the money in your bank account, the number of trees in a forest, or even something abstract like your self-confidence. And then you have the flows. These are the things that make the stock go up or down. So the faucet is the inflow, adding water. The drain is the outflow, taking it away. Now here's the key thing to get. Stocks, they tend to change pretty slowly, but flows can change really fast. And understanding that dynamic, that push and pull between the stocks and the flows, that's the very first step to understanding any system. Right, so what's actually controlling these flows? Something has to be telling the faucet to turn on or telling the drain to open up, right? And that brings us to the real engine driving the whole thing. The secret, the absolute core of it all, is something called feedback loops. This is where information about the level of the stock, how much water is in the tub, actually travels back to influence the very flows that are changing it. A feedback loop is basically a closed circle of cause and effect. It's how a system ends up causing its own behavior. And really, there are only two main kinds of these loops you need to know about. First, you've got reinforcing loops. These guys just amplify whatever's already happening. They're what cause those massive runaway changes, either virtuous cycles where things get better and better, or vicious cycles where they just spiral downwards. Think of a snowball rolling downhill. Then, on the other side, you have balancing loops. These are the stabilizers. They're always trying to hit a target or a goal. They resist change and try to keep a stock steady, just like a thermostat does in your house. So, a perfect and kind of scary example of a reinforcing loop is the security dilemma. It works like this. Country A builds up its army to feel safer, but now its neighbor, Country B, looks over and feels threatened. So what do? They build up their army. And that, of course, makes Country A feel less safe than before, so they build up even more. See the loop? Each step just reinforces the next, creating this runaway arms race that nobody really wanted. And for a balancing loop, the thermostat is the perfect example. It has one goal, right? A specific temperature.
If the room gets too hot, the thermostat senses that gap between the actual temperature and its goal, and it kicks on the air conditioner. Then, as the air cools down and gets closer to the goal, it shuts the AC off. The whole system is just constantly working to correct itself and keep things stable.
Okay, so now we have our toolkit, right? We've got stocks, we've got flows, and we've got feedback loops. With these concepts, we can finally start digging into why our brilliant fixes fail so often, and more importantly, where the real power to make a difference, the true leverage, is hiding. All right, so if a system's behavior really comes from its own structure, and we now have the building blocks to see that structure, why do we still mess it up so often? Why do our solutions just keep missing the point?
It's because we're trained to look at the wrong thing. We focus on events, the daily news, the quarterly profit report, the crisis of the hour. We blame the people involved. We're just not trained to see the patterns of behavior that unfold over time, and we're definitely not looking for the hidden structure that's causing those patterns to happen in the first place.
Let's go back to that Dutch teacher shortage for a second. The so-called logical fix was to create this introductory module to get STEM students interested in teaching. And, it kind of worked a little, but look at this table. The real story, the critical flaw, is hiding in that very last column. The percentage of students who actually went into teacher training after they took that intro class. Yeah, just 12%. At Delft University, after all that work to get them interested, only 12% of them actually followed through. So the problem clearly wasn't a lack of interested students, was it? No. The real issue was some kind of structural breakdown happening somewhere else down the line. And that failure right there, it perfectly sets up the most important concept in all of systems thinking: leverage points. Donella Meadows actually created this incredible hierarchy of where you can intervene in a system, and as you can see, they are not all equal, not even close. We spend almost all of our time and money way over on the left at point 1, numbers. We're always tweaking taxes, fiddling with budgets, changing standards. These are the easiest things to do, but they're also the least effective. The real power, the true leverage, happens as you move to the right. Look at point 8, the rules of the system, the incentives, the constraints. Or point 7, information flows, who gets to know what and when. That's way more powerful. But the biggest leverage of all, it's way over on the right. Point 10, changing the system's fundamental goal. And then the ultimate leverage point, number 11, changing the paradigm, the deep-seated shared beliefs that the entire system grew out of. That is where you can create truly transformative change. So you see, the big takeaway here is that looking at the world as this web of interconnected systems, it's not just some cool academic idea. It's a real practical toolkit. It gives you a new way to see and a new way to create change that actually sticks.
And this quote, this really gets to the heart of it. It's the ultimate insight. All the physical systems we see around us, our economy, our schools, our companies, they're not just there. They are all born from a paradigm, a shared set of ideas and assumptions about how the world is supposed to work. If you can change that shared mindset, you can change anything. And with this new lens, we can finally solve the mystery of the Kenyan textbooks. The program failed, but not because it was missing an element, the books. That's a low-leverage fix. No, it failed because there was a flaw in one of the system's rules. The national curriculum was just way too advanced for most of the students. They couldn't even use the books they were given. The fix was aimed at a visible symptom, but it completely missed the deeper structural cause. And once you start seeing the world this way, looking for the stocks, the flows, the hidden feedback loops that are driving everything, you can't unsee it. You stop blaming individuals and you start asking questions about the structure that's forcing their choices. So I'll leave you with this. Take a minute. Think about a problem, any problem, big or small, in your work or your life. What's a problem that you see differently now?